With this done, we come to the last problem of this course. Let m and n, non-negative integer. Each member of a parliament has at most m enemies. The notion of an enemy should be mutual. So if A is an enemy of B, then B is an enemy of A. You can in fact easily check that the problem would be false if it wasn't mutual. Now prove that it is possible to subdivide the parliament into two houses such that each member has at most m½ enemies in his own house. And yes, just in case, houses can be empty. So if like there is only one member, you don't have to break this member apart in some way. So how does this work? This is a problem where there is no visible process or movement or algorithm involved. So it's not quite clear where to find a monovariant or for what to find a monovariant. Nevertheless, you can find a monovariant. You just have to first find the process. So what's the process? We start with some arbitrary subdivision of the parliament into two houses. For example, you can just put everybody in house 1 and leave house 2 empty. Now, a member of the parliament will be called unhappy if he has more than m½ enemies in his own house. So we want to achieve a subdivision where no member is unhappy. This is what the exercise claims that we can do. And the question is how to do it. Well, okay, we have started with some arbitrary subdivision, and what we do now is, as long as an unhappy member exists, just pick an unhappy member and move him into the other house. You can easily see that he will no longer be unhappy after you do this. Now the question is, of course, is this enough? It might make some other members unhappy. So per se, you could imagine that these moves could go on forever and ever, and you would never find this kind of subdivisions that you want. However, I claim that these moves cannot go on forever. Indeed, we define the total unhappiness to be the number of pairs UV. Actually, let me say total discord, because it's not really the total. It's not really defined in terms of unhappiness. We define the total discord to be the number of all pairs, okay, of all two-element sets U, V, consisting of two parliament members that are mutual enemies but belong to the same house. Then each move decreases the total discord. How do you see it? If you look at an unhappy member, basically you can view, if you focus on a single parliament member, the unhappiness is his contribution to the unhappiness is how many enemies he has in his house. His contribution to the total discord. And if he's unhappy, then he has more than m/2 enemies in his house, and therefore less than m/2 enemies in the other house, because he has at most m enemies. And this means that if you move him off into the other house, he will then have fewer enemies than before in his own house. So the total discord will decrease. But the total discord, this is now an idea that we have seen many times, the total discord is a non-negative integer, so it cannot keep decreasing forever. Therefore, the moves cannot go on forever. And of course, when eventually we reach a state in which no more moves are possible, which means that no more members are unhappy, because unhappy members make moves possible. And this means that each member has at most m½ enemies in his own house. And that's it. We have at this point seen enough invariants and monovariants that you should probably know how to use them in reasonable situations. Of course, there is no bound to how creative you can get with these methods. There is always harder problems.